So we are going to go into 9.2. I got to say, this is a lot easier than the last section. I have a lot fewer notes about, oh, got to remember this on the homework, because it's basically all there in the workbook here, minus or plus just a couple very small things. So what we're going to be talking about today are the confidence intervals using the t-distribution. So basically, we've already seen this from last time. We're going to have a mean plus or minus some amount of error. Let me rewrite it here because I know it's been a while. Can I talk about it for just a second? So mean plus or minus some error. Again, how that looks is mean minus some error, and then the mean plus some error. Okay, so I want to be confident in something that I'm going to state in a newspaper or a magazine. I'm going to say, hey, I want to be 95% confident about what I'm going to say. Let's do 30% of Americans like pizza. Okay, that's my statement. But I want to be 95% sure that I'm going to be hitting that correctly. Hello. So instead of saying exactly 30, maybe we should do some plus and minus. Yeah. What if I said, nah, it's not 30, it's 28 to 32? Make sense? So we're going to start in the middle and we're going to work out some plus or minus. And that's what we're going with. The t-distribution is separate in StatCrunch. Okay, so we're going to use just t-distribution. Why are we using it? It's because we basically don't have a whole lot of sample size. It's designed for smaller sample sizes. Now, before we keep going, I got to say right here is huge, 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 huge. Degrees of freedom is simply n minus 1. Okay, so that's all it's going to be. Let's say I had a sample size of 20. My degrees of freedom would then be 19. Exactly. If I had a sample size of 35, my degrees of freedom would be 34. There you go. We're only minusing 1. Now, that's going to happen when we go to StatCrunch here in a few minutes. They're going to say, hey, what's degrees of freedom? Just subtract 1. Is that okay? So that's one little thing there. I can give you a whole big talk about what it really means, but I think it's better just minus 1 is good. Cool? Degrees of freedom, minus 1. Scrolling on. Let's scroll. Sample size. Sample size, minus 1. That's all we're doing. Yep, so if I take a sample of everyone here, 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 1 from it, you get 8. Cool? And that's what we put in the StatCrunch. Yeah, they're just kind of getting you prepped for StatCrunch. Whenever I ever use tables, never. This looks like a whole lot here, and really, honestly, it's way better just to go and use some StatCrunch. So I'm going to pull up the homework just so I can get some StatCrunch going here. And we're just going to use that. You're back. Okay. StatCrunch. If you have any questions along the way, let me know. But this is what I'm going to start showing you is what are we going to do with this section and everything like that. Scroll this a little bit. That's good. Okay. Perfect. See how it says n is equal to 14? So what is degrees of freedom in this case? 13. Easy enough. And they say, go and find out where this is going to be for 90%. That's 90% in the middle. So I'm going to say that's a between 90%. So what value would we be looking at? So here we go. I'm going to now give you what we're going to do. Stat, t-stats, one sample, and then with summary. Stat, t-stats, one sample with summary. Oh, yes, we did proportions. Last time we did proportions, one sample with summary. But now we're just doing t. So you can see it's going to be a very similar thing. Let me start writing that down. So I'm going to go StatCrunch. We're going to go stat t, one sample with summary. Okay, so I'm going to click it. And we got some stuff that we're going to fill in here. We're going to keep it very basic here. Actually, you know what, guys? I want to do this. This is actually going to be the next question. I'm going one step too far. Can I back up for just 1 second, if you don't mind? Okay, this is good, and I think I can get the right answer, but I'm going to go back real quick. Hold on. What if I did stat calculator t? That's what I want to do right now. I'm so sorry. Forgive me for just 1 second, okay? I will come back to that one. We will do that here on the next problem. And we can use it now, but then we have to kind of hack it, and I don't want to do that. I'd rather just give you the right answer. So StatCrunch, and then we're going to go stat calculator T for just a moment. Stat calculator T. Are y'all okay? It's still the T stuff, and this is just going to be a little bit better, I promise you. So we're going to do between, and I'm going to put in right here 90, because it says 90 between. But what is my degrees of freedom? Say it says DF. What's my degrees of freedom? 13. And I'm going to make sure I got the 90 there. There, we're done. That's literally all we have to do for this problem. The other way is going to be a little longer. I think this is better. Hello. Did my thing go out? Oh no, bro. You want to play my laptop? No. Oh no. It's okay. It's okay. It'll come back. Okay, there we go. Now it's good. Okay. Yeah. Yep. Yep. And then 90, and then you hit enter. Here, I'm gonna check. Sorry, guys. No, no. Oh, 0.9. 0.90. Yeah, for like 90%. Because it's n minus 1, notice that it was 14. The formula, it is very straightforward. The formula is literally just sample size minus 1. And that's what the one thing we have to use. That's a little weird, but it gives you the answer immediately. So 1.7709 is what the answer they're looking for. Nearest thousandth, I think, is just 1.77. But that's it. That's all we have to do with that one. Okay? Is that okay? I think this is going to be better than the other way. The other way we will use, but just this is faster if we're just getting the confidence interval stuff. Cool? Let's do another one. So then this guy. I have a sample size of 10, so my degrees of freedom would be A. Awesome. And then we got 99%. So let me go and put those two numbers in. 9. And here I'm going to put 0.99. And we're done. Literally, that's how fast it is. And that's why I chose this method versus the other one. I think if you round it nearest thousand, it would be like 3.25. I want to draw a picture, though, too. Pictures are so cool. Yeah. So I did the 13. Oh, this thing? Oh, I don't know. No, I don't. I don't even know why it's there, but it looks like the same picture. I guess I would put negative 1.77, 1.77 right there, but I don't know the rest. Maybe this would be like 90%. I don't know what they're wanting. Yeah, somebody else made it, so. Is this easy though? Like when we come to the homework, you could just pop that in right quick. We're done. All right. Okay, cool. So yeah. So we're gonna use the other one here, like right now. Actually, the next problem uses the other way, and it's gonna be very fast and easy. So cool. Good. I'm gonna scroll on then. Okay. So real quick before we keep cruising, right here. Normally, I don't really read a lot of this stuff, but this thing right here is on homework number 6. So on your homework number 6, it's going to have a multiple choice question, and it's going to be about that. And basically, you just select it. That's not hard, but now you see it. Hello. Cool with that? Keep cruising. That's why it's there in the workbook, because it is on the homework. Okay, so it's just like what we did last time. We're going to do the confidence interval stuff. I'm going to show you how to do it. But kind of like read the problem for a second. I'm going to read it with you. We got 6 microwaves, and their average is $60. And we got a plus and minus of $13, blah, 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 blah. I want to go and say, for all of America, what's the average microwave price? Yeah, but I only have 6. That's not very much, is it? And that's the problem here. That's why we're having to use this t-distribution stuff, is because it's a small sample size. But here we go. So I got StatCrunch, of course. Hello. So stat, t-stats, one sample with summary. Just like I was talking about last time, but this one's the actual problem. Okay. So here we go. Stat, t-stats, one sample with summary. Yes? I'm going to have to put some stuff in. So it says, hey, go ahead and put in the average. What was the average price that we had? 60. What was the plus minus standard deviation? 13. I mean, you can put 00 if you like. It don't really matter, but that's the thing. What was my sample size? How many microwaves? 6. That was terribly drawn. Try to do that a little bit better. There we go. And then, because we're doing confidence intervals, I want to click here, and it says 99% confidence. So I'm just going to put a 99 in there instead. So I'm going to start copying some of this down, and then we'll go from there. So mean, I have a 60 standard deviation. Hello, hello. Oh no, is there a bug? Do you want me to stomp it? Do you want me to bring it outside? I'm coming to it. I'm coming. Hold on. I'm going to fill this in. Okay, I'm coming. Can I like just hold him and hug him and love him? Oh, that's like a stink bug or something. That would be the worst thing ever, wouldn't it? You might want to like run away with it. You want to name it? Yeah, I have 3. No. Who wants him? That'd be crazy. Stinky is set free. I could have stomped them though, but that would have really stank, actually. Hey, thank you guys. All right, good thing we talked about that. Okay, so I'm gonna hit compute. Boom, and we got some stuff here. So we got my lower limit and my upper limit, and we are done with this problem. That's all we had to do. You did not? I am coming to you in just 1 minute. So like 2 decimal places. There you go. Oh, it's a little off. Go options edit. 99. Oh, 13. Standard deviation 13. Yeah, it happens. It happens. All right, cool with that? So I can now say, given these 6 microwaves, which is very little, I can say I'm 99% confident in all across America, the average price for microwave is somewhere between 38 and 81. 38 and 81, look at that spread. Isn't that crazy? Like, okay, I want to be 100% confident. Microwaves in America cost anywhere between $0 and $1 million. Am I 100% confident in that? Right? No, yeah. I mean, unless you know of a microwave more than $1 million, right? So it's kind of a big spread because, again, I want to be 99% confident. Is that okay? We're good with that? Math one. Go ahead. Go ahead. No, bro, right now's the time. Yes. 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 This is the same thing as last time. It's just that we're doing it with T instead of the P. That's all. Yep. It's almost the exact same thing. Almost. So I have a random sample of 23. I have a mean. I have a standard deviation. 80% confidence. Do it. So here we go. I'm going to go and do it. Same thing as last time. My mean, 30. You got it. Standard deviation, 7.2. Sample size, 23. Confidence of 80%. I'll write it down if you want me to. I'm going to write it just so that you have it down for the notes here, what I'm doing. But you can see this is your homework, and this is the section. It's actually much easier than the last one. Is this okay? Are there any questions? Yeah, definitely. Yeah. Do you want me to just leave it where it is? Or do you want me to just hit compute? Hit compute. So I got my lower limit. I got my upper limit. So I'm 80% confident that the average time for all of America is between 28.4 and 32.4 minutes. There you go. Cool. They're going to ask for this margin of error thing. I thought that it would be the 1.501, because see how it says standard error? That is not the case. That is not how you find it. We actually have a formula for margin of error. If you remember, it's upper minus the lower, and then divide by 2. That's my margin of error formula. Do y'all kind of remember that? I know it's been like a week and some. Let me get some Desmos on the side here. Yeah, margin of error. We're going to do the upper minus the lower divided by 2. Oh, is it just literally 2? 2. Yeah, well, there you go. That's what we got. Easy enough. Last one. Last part. And I know that we can do this one. With confidence. With confidence. We always have to answer with confidence. Okay? Because you're answering confidently. Blah, 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 blah. Population mean time. That's your key words. Like, let's not make it complicated. They're going to give you 4 options that looks just like this. With confidence, look for the population. Done. Cool? Very straightforward stuff. Your homework looks just like this. Awesome. Okay. Just checking ahead on my notes here. Okay, cool. Good? Rock and roll, here we go. Next one. StatCrunch notes. I actually have something from the homework, and I want to just tell you this small little thing here. On homework number 7 and number 8, we need to use the with data. So I'm just going to tell you it's the stat, tstat, one sample with data. And I'm going to show you one of those here in just a few minutes. It's really simple. Just use the with data. And whenever they say the word point estimate, they mean the mean. Point estimate, it's the same as the mean. Okay? That's just like a little side note right there. All right, cool. We're going to see that in a few minutes. I'm not worried about it. I'll show you when we get there. Hello. So I got to say, this next question here is really cool. It's talking about, what is it talking about this time? I don't know. It's talking about something. But the homework question for this is actually way better. So I'm just going to do all of this right here. I'm literally not going to do any of this. This is all homework number 9. And I'm going to do that here with you like in just a few minutes. So I'm going to show you how that works, okay? But this is all homework number 9, all this stuff, all this stuff, all this stuff, all this stuff, all this stuff. And then finally we stop right here and do something new, okay? So let me go ahead and give you a little bit of picture-wise on what's going on here. This is just multiple choice that we're going to find on the homework as well. They're going to say, hey, what happens when you change the level of confidence? So can I give you some examples and we can talk about it? Let me give you some pictures here. What if I were to say I was 80% confident? So let's call this 80. And they're saying, what happens if you increase it? So what if I go from 80 all the way to 90% confidence? What happens to this area here? Yeah, it widens. Yeah, see how it got wider here? It spread out more. But isn't that the point? 80%, 90%, 99% just gets bigger. So that's super easy. Increase of sample size. I'm just going to give you a picture. This one's more of just like I have to tell you. So if you have 10 people, then it's a little bit more spread out. But if you have like 100 people, what happens is that you start to hone in on what the population really is. So if I showed you these pictures, and I'm saying sample size is getting bigger, what would happen with the spread of this thing? Narrower, yeah. And I'm just giving you pictures of what this looks like. I can show you here later. Last one. The spread says the standard deviation is the spread. So they're saying that my spread gets bigger. Let me just go ahead and fill it in here. So this is my sample standard deviation. Say it's 1. And now I'm going to say it's a 2. What happened with this thing? Yep. So on the homework, they're going to ask these kind of questions. And now you just go back to the workbook and reference it, right? It's really multiple choice. Yeah. Yep. Yep. That's a good question. I would say that the confidence is going to be like straight up what you're asking for, right? 80 to 90, you know exactly what kind of bell curve that's going to look like. The standard deviation, I'm literally just moving it by like those like jumps in a way. Notice I went from 1 to 2 and it doubled essentially. So here, 80 to 90, and it got bigger. I would say more standard deviation is a much bigger change for sure. Cool. Okay, cool. Is it coming back? Where's my screen? It's all over. Wait. Okay. Are we still recording? We're still recording. Great. Okay. All right, cool. All right, last topic, and then I'm going to start some homework questions up, okay? Minimum sample size. Let me swap to the next page right quick. This is pretty important, but we're going to do, let me put this on the side here. We're going to use the table. No. Yeah. Yeah, we're going to use the table from page 139. Yeah. I'm just triple checking here because that says the z-score there. So yeah, we're good. I'm going to just use that and it'll be fine. Okay. Do you remember page 139? Can I go back to it real quick? I'm going to go back real quick. This is way back. Way back. This is the only table I ever really cared about. Way back. Yeah. Way back. Where did it go? Page 139. Right here, this guy. Oh my gosh. There. So they're going to have confidence level, and you can just pick one of these z-scores. I'll remind you when we get there, okay? But now you see it. That's what I'm talking about, okay? I'm trying to give you like just the quick version of what do I do when I see this on the homework. You're going to do this thing, and there you go. So let me put it together, and we're going to do some math here, okay? This is more basic math stuff. College Board, sample size, estimated standard deviation to be this much. Now, I think that this right here is a year, 2016, like that's the year. So I don't think I'm going to use that. I don't think at all. So I got a standard deviation. 90% confidence, within 40, What's the minimum sample size? Okay, so here we go. My n is equal to, I got z times s all over e, and then all squared. What would be my standard deviation? Like, what's s out of my numbers I have here? What's my standard deviation? 192. Yep. See, it's a standard deviation, blah, 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 192. But you're right. So what would be my error is the within the 40. I'm going to square the whole thing. And this is the thing that I need to find from the table. So I'm going to remind you here, confidence level of 90%. That gives me a z of 1.645. So that's what I'm going to just toss in there. Yep. There you go. I'm just giving you, that's what it was from the table. I'm just tossing it right in there. And then I'm going to do some math with this. If y'all have questions, please tell me, man. I'm just giving you some, like, this is basically, hey, how do I do the homework, Chad? You do it like this. And we're going to go do that here in a second. Oops. There we go. I know it's been a week. Man, a lot of this feels so disjoint because it's been a week now. But do you remember what I do with this number? I have to always something with it. Round what? Round up. Yeah, I know. It's very strange. We're going to have to round up. One of those, like, always. Hey, Chad, when do I round up? It's kind of weird, isn't it? So I'm saying always go to the next one. Can I give you a reminder about what I'm talking about here, about rounding up? Let's say this is like soda bottles going through a conveyor belt, right? And I'm supposed to get 62 and a third, and I'm going to test them. So here we go. Psst, and I drink one, psst, and I drink two, psst, and I drink 60, 61, 62. I pull out the 63rd, psst, I just go, I only want a little bit, and I put it right on back to this conveyor belt. That's not going to be good, right? Someone's going to get a third open soda bottle, right? Might as well just drink the whole thing. And that's the point of rounding up. We're just going to go ahead and do the whole thing, okay? So now I have a 99% confidence. The only thing that's going to change is my z. Can some of y'all go to that table on page 139 and tell me what the answer would be? For 99%, what would be the z-score for that? Page 139. Can you? There you go. 2.576. Very good. That's exactly right. We're tossing that thing in, and we are done with this problem. 2.75. Oh, look, guys, I'm dyslexic. It happens. And then I have a 192 all over the 40. And I square it, pop it all in. Let's get an answer. 576. Okay. So 152.89. What's my real number? 153. You got it. Okay. So it says as the confidence increases, we went from 90 to 99. What happened to the minimum sample size? I went from 63 to 153. So what happened here? From here to here, what did I do? Increased. Yep. Exactly. Increased. You're right. And then we're done with that section. I definitely want to pull up the homework. Yeah, that's all. This is more of just a reference guide, I think, for what the homework looks like. I don't know if you, by now you've probably figured it out. The workbook's okay, but it doesn't really show you everything on the homework, right? So that's why I pull up the homework in class, because I want to show you what's going on with it, you know? Are you cool with that? Yeah? Yeah, go ahead. I'm fine waiting. There's no rush here at all. This thing. Yeah. Right here. Yep. See, estimated standard deviation, and this is a year, 2016. That's a year, so I don't count that. Okay. Exactly. This, yeah. Standard deviation score is 192. Very good. That's right. Yeah. Oh, you're fine. You're fine. You're good. Yeah. I'm just gonna start pulling up the homework. The first questions are super easy. You okay? Did you need help at all? Okay. All right. I'm going to pull up the homework. So here we go. I'm already here. So that's kind of nice. So it says find the t-value for right tail test, 25 degrees of freedom. And really, we didn't do right tail tests. What does that even look like, right? So I'm going to have to pull this thing up and start working on it. In a way, I feel like without me doing the homework, I'm going to be lost a little bit. It said here, right tail test for 1%, but I never did that. I always did a between on the workbook. So here we go. Stat, calculator T. Stat, calculator T. There was only the two places we talked about today. This is the first one. And it says on the right side, I want the 0.10 or whatever. Now, it says 25 degrees of freedom. 25. I put it in there. And then I want this to be 1%. But what is this? Is this on the right side? No. It said on the right tail. That's a left tail, isn't it? So I got to flip it. Okay, let me flip it. So I'm going to change this little arrow thingy to the other side. Oh, well, hold up. That's not 1% anymore, is it? So it's 99, so I got to change it again. Back to 1%. Oh. Let's try it. 2.485. There we go. Right? So it's all in StatCrunch. Everything's there. We just need to know where to go, right, and what to do. Now it says the right tail for, what is this percentage now? Yeah, 10%, exactly. So let me change it to 18 here. 10%. Toss it in 1.330. There you go. Yeah, it says on the left side, 20%, 14. So 14 degrees of freedom. Hold on for a second here. 20%. Oh, but hold on. That's on the right side. Yep, change the symbol back to the... Oh, I got to go back and change this guy. Back to 20%. What is that thing doing in my way? Go away. Now, what's interesting about this, it's a negative number, right? They're going to be very angry with the negative. They're not going to want the negative. Oh, they want the negative. Okay, cool, man. They want the negative. Just do what they say. I really thought it would not because they were looking for the number. Anyways, are we cool with that? I mean, look, even StatCrunch showed you the negative side, right? And so then it says 95% confidence. Now, this is what we did in the workbook. We didn't do left or right. We were doing between. So here we go. I got 21 degrees of freedom. And they say, what was it? 95% confidence. So let me put that in. 95. 2.0796. What would that be? Would that be 80? There it is. There it is. See you later. Thank you. Cool with this? Yeah? Is that easy peasy? I know that's only question 1. How many more questions? Oh, it's only 11. There's only 11 in this section. That's not too bad. Okay. Point estimate is the mean. And we had a formula for this. I'm going to remind you. This is actually from the last section, so it kind of feels a little weird that we're doing it all over again. So the mean, the average, was the upper plus the lower divided by 2. It was my error that was the upper minus the lower divided by 2. So those are my two big formulas. They said find the point estimate, find the mean. I'm going to just take them as I go, I guess. So 28 plus 16 divided by 2. Cool. Margin of error, 28 minus 16 all over 2. Right? And this is why we do the homework, because, I mean, I don't remember seeing that directly on the workbook. That was like from the last section. But is the math easy enough? Yeah? If you ever tell me, like, hey, Chad, go back. Hey, Chad, slow down. Hey, Chad, tell me what's going on. I'm here for you. You just tell me, okay? I just want to make sure that you see what I got here. And I know I'm recording, and I just want to make sure you're good. Yep. Cool?
And I promise I'll record the chapter applications one. I was just way too excited with the business calculus stuff. It happens, right? No? Okay. Taco Bell. Who in here likes Taco Bell? Taco Bell, yeah. Y'all don't like Taco Bell? Okay. Okay. There you go. Yeah, no, I get you. So I'm gonna put this stuff in here. It says, "What's the mean for this thing?" I don't know what they're trying to get at. This is the same as the last one, essentially. We're just doing the mean is upper plus the lower divided by 2, isn't it? So I'm looking at my two numbers. Do you see how we have a lower and we have an upper? This is exactly the same as the last problem. It's just bigger numbers. So 173.1 plus 169.5 all divided by 2. So I was getting all excited to do StatCrunch, but this is supposed to be way easier apparently. Okay, cool. There we go. Look. Oh no, there's more to it. That's okay. We can do that. Are y'all okay using the same formulas the second time? Right, copy paste the same formulas for sure. I'm gonna scroll on then. And now it says blah 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 confidence, this and that. Okay. Weren't we talking 99% confidence? So we got one can be blank confident. That's going to be one of these guys. That the mean drive-through time at Taco Bell, that a mean drive-through time at Taco Bell is this much? Or is between these much? Between, yes. Between, and then the two numbers they gave you. 169.5. 173.1. There we go. So it looks scary at first, but like honestly, I didn't really do much math there. I'm looking for the ones that use StatCrunch. That's the real thing. But y'all okay with that? It's pretty straightforward. Okay. Let's see what else we got here. I want to do some StatCrunchy stuff. I think this one finally we get the StatCrunch. Let's do this one together. That's an excellent question. Okay. So here we go. I'm going to do stat, T-stats, one sample with summary. So this is the big one. This is the usual, the thing that we did at the end a whole lot. And I have a mean. What would be my mean? Look around here at my numbers. Which one would be the mean, the average? Yeah, the X part. Yeah, exactly. 13.4. Sample standard deviation. Yep. There you go. And then sample size. You can see we only got 4 numbers, right? So which one's the sample size? Yep, exactly. 956. Confidence of 95. We already got it, so we're good there. I'm going to hit compute. We got my lower and upper. So there's a 95% probability? No. Blah, 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 confidence. Right? Always with confidence. Between two numbers. And here we go. I got the 12 point, 2 decimals, 45. And the 14.35. Check it, and we're good. That's the whole problem. But now you can see how I'm using the StatCrunch, just like we were doing on the workbook. Yeah. Oh, good. Yeah. I did. Let me get rid of this. Stat, T-stats, one sample with summary. Yeah. Stat. Yeah, stats, T-stats, one sample with summary. We were going to do the with data here in a second. Yeah, that'll be, I think, was it number 7? And then there's number 9. Yeah, number 9 we got to do together for sure. I want to do that with you. Okay. Yep, exactly. Is that good now? Good to go? Thank you. Okay, cool. let me find the one that I wanted to talk about, number 7. Like all these, I'm not worried about. Aha, here we go. So they say find the point estimate, blah, blah, blah. And it's only part 1 of a few. We could do this. See how here it says open in StatCrunch, right? With that little button. It's been a while since we had that, haven't we? Open in StatCrunch. And I got all my data. So now, this is the time. Stat, T-stats, 1 sample with data. This is that one moment where we've got to use the data, right? With the 0 selected? Yeah, that's new. Yeah, that's new to me. Yeah. No, I guess it's both of us now. Yeah. Yeah, that one's weird. So yeah, click on the first one, of course, and we're doing the confidence again. They didn't say what. Maybe I didn't write that one down, so I'm gonna see without changing it. Yeah, we'll check it out. So it says, what's the point estimate of the mean? Basically, just what's the average. And so I don't know about the confidence level. I'm just gonna hit compute on this. Are y'all cool with that though? I'm gonna hit compute, and they have right here the mean, and that's all I'm gonna put in. 5.01. No, that's gonna be a 2 technically. There we go. And then they go into the confidence interval. Notice that it says 95. Well, happily, thankfully, I already put in a 95, right? But if I had to, I can go back and change it to like 99 or whatever it is. So out of these guys, out of these options here, 95 confidence, with confidence. I put in my lower, put in my upper, and then we're done. Here, I'm coming to you. Otherwise, you get weird numbers. Those should work. Well, we had different numbers though. Here. Yeah. No, you did good. No, you did good. It was good. Yeah. Sorry, guys. I'm like fighting a sneeze right now. There's our happened to you. It's like wanting to get out. Yeah. So here's the last one. 99% confidence. All I need to do is change one number. 95 goes to 99. I put in the numbers once again and we're done. Confidence between 4.72, 5.32, and we're good. Okay. So, this is that increases, decreases stuff. I got this one wrong one time, and then I had to redo it because I was being silly. But if you think about it here, I'm going 5.81, and now I'm going 5.72. So I'm going like further away from the average. And the same thing with the other one. I got 5.23 to 5.32. It's actually getting further, bigger, wider. So I'm going to say it increases. It increases. But I don't know which one of these it's supposed to be. Including more numbers, all confidence, fewer numbers. I think I'm going to try that guy. I don't know. Oh. Including more numbers for consideration makes them. But I don't know if I don't think I was adding more numbers. Okay, I'm gonna. Okay, it wanted that one. Click that one, guys. The more numbers for consideration. Oh, okay. Right, this goes way back to a concept thing. They're just saying we're going from 95 to 99. That's more. That's just more. What? This one? Point estimate? Yeah. So I got that one from right here, upper lower, when I did the 95. Oh, it's always 95% confidence? But you're in the right place. Is this cool, though, with the data? It was with data. We're good with that? Okay. Then I got to show you number 9. And this one's going to be the big one. After this, everything else is really easy. All right. Man, something about this tornado data. Let me tell you what. So this is a 7-part problem. I want to do this with you because it is crazy. Number 9. So if you look at the data, we got a lot of data. It is crazy. So we need to know what they're wanting. Does that make sense? So this is why I want to do this one with you, because it's just crazy. There's a lot going on here. Compute the population average for this and that. They just want the average. So there's a few ways we can do this, but I'm going to do what I'm going to have to do. The t-stats, one sample, and then with data, I think, because there's a whole lot of data here. Are y'all okay with the with data part? And I'm going to click on something. Now it says the mean length of a tornado. There's length right there. So I'm going to use that one. Confidence, 95 is fine. We can change it later if we want to. Sorry. All right, cool. Here we go. Compute. Let's see what we got. There's my mean. There's my average right there. Copy paste. 3.6. Okay, cool. There you go. Guess the tornadoes haven't changed. Yeah. Okay, so it says, hey, which of these graphs makes sense? Okay, now hold on for a second. Hold on. This is not going to happen with just that one little guy. We need to do a lot more. I'm going to go to graph, bar plot, and then like with data. Is this okay? I'm going to try this thing out, see what happens. And we're doing the length. It says relative frequency. See it how it says relative frequency everywhere? So I'm going to click on that instead of frequency, relative frequency. Now I'm going to hit compute. Let's just see if I get something at all. Lots of unique numbers in length. Turn on binding procedure. I don't like that. Do you like that? That doesn't look good. Let's try something else. Let's do histogram. And again, length, relative frequency, compute. Okay, that looks a little bit better. Definitely not perfect, though. If you had to pick an option, which one do you think it ought to be? You like A? D? I like D. And the reason why I like D, and I know it's kind of small here. Let me kind of zoom in a little bit here. I like D because it starts here at 0, 0. Yeah? All the other ones are not. Do you see how they're starting somewhere else? That one starts at 0, 0. That's my favorite. And it is skewed right for sure. Very good. Skewed right because the peak between 0 and 8 and then a tail on the right side. Yep. Okay. Big timeout again. They want to figure out this, I think it's a box plot. And we're going to figure that out. I have it written down here. Okay, so I'm going to have to do another graph. I'm going to go to box plot. Right here, box plot. Graph, box plot. Again, length. And I'm going to hit compute. And that looks kind of funky. Honestly, I don't really like it. But it is telling something. Let me see if I can make this a little bit better here. Right here, draw boxes horizontally. Okay. I did graph box plot. Yep, graph box plot, and then I did the length, and then I chose draw it horizontally. Now, let's time out for a second here. I got A, B, C, or D. Do you see the differences between them? Is only where the X's are. Those are supposed to be outliers, I guess. If you had to pick which one you would want, A, B, C, or D, which one do you think would be a little bit better here? Just take a guess. D. D. That's my thoughts also. You see what's going on is that all of these right here are separate dots. So we have our little box, and there's a whole ton of dots out here. Which one has a whole ton of dots, essentially? That's all we're really doing. Yep. Are there outliers? Yeah, a lot of them. Okay. Is this part 7? This is part 6. Okay, so it's still multiple choice. Explain why a large sample size is needed. Skewed right. Yep, skewed right. That was easy, no problem. Okay, now, this is the moment, and I'm glad I'm recording it. Let me make sure my thing's good. We're good. Okay, this is the moment. I have something written down specifically for part 7 of this question. Okay? What we need to do is stop everything we're doing there, and we now need to use this right here, the subset of tornadoes. It's a whole separate set of numbers. This is what we have to use for part 7. This is what we're using for part 7. I cannot stress this enough. I got this answer wrong because I was using the wrong data set. As soon as I did this, it was no problem at all. So here we go. Stat. I'm going to do the t-stats, one sample, again, with data. Stat, t-stats, one sample with data. Yep, var1, very good. And then confidence, 95, they already have it. I'm going to hit compute. And so we got right here, 95% confidence, mean length for tornadoes, like the whole tornadoes in all of America. The population, hold on. What is the numbers here? 2 decimals. 2.24. Yeah, and 8.85. 2 decimals. Again, I chose this last one because it was with confidence, and it says the mean length of all tornadoes in America, essentially. The population. That was the point that we needed to click on that one, okay? So I got through that one. The last two are just the minimum sample size stuff, which is very simple. We already did that. It's simple math. Any questions on this question here? You feeling me? Good? Okay. We got a little bit of time. The more time I spend right now doing stuff, the more time I get to review with you next week. Is that okay? So we only have a little bit more time, not too much. I'd like to spend a couple minutes with y'all doing the next section, okay? And it's really fun. The homework is only I think it's only 10 questions. They're all multiple choice. Maybe it's, I'm sorry, I thought you were like, yeah, and I'm like, oh, okay. The next section is very simple, and it's all multiple choice. But I want to talk about it. It's a talk about it question, section. 5, 4, 3, 2, 1. Here we go. Hypothesis testing. See you later. So, hypothesis testing. I got some stuff to fill in the blanks, and then I'm going to start talking about it, okay? Hypothesis test is a process that does all this. Null, and then alternative. Alternative. My handwriting's not perfect, but there you go. Hypothesis test, null, and alternative. Let's talk about this. Someone makes a claim. I'm going to make a claim right now. Are you ready for my claim? 50% of Americans are female. There you go. That's my claim. And I want to know if that's correct or not. So now you're going to start to go test it. You're like, no, I don't think so. Isn't it that males die earlier, heart disease, all this other stuff? Okay, I thought that was a thing. I'm pretty sure, okay? So maybe it's 51%, maybe it's 52. I don't really know. But what I'm going to do is start testing it. So I start gathering a whole lot of sample size and I say, hey, blah, 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 blah. This is what I found. But what if you found 52%? Is that far enough away that my claim is wrong? What if you found 60% of Americans are female? Is that now 50% is now wrong? What if you only found 50.5? Is my original claim wrong? You see what I'm saying? How do I prove me wrong? It's through this math, okay? So what I'm going to start doing with you is I'm just going to roll with these questions. Again, the homework is literally all multiple choice. So you can just breeze through it. but it's a good discussion topic here. So when you have questions, you talk about it, we'll go through this together. It's going to be fun. Okay. So this one here is called the null hypothesis, is what I would call like the status quo. See you later. I would call this the status quo. Wouldn't you say 50% of Americans are female? It's kind of like a known thing, yeah? And so what they're saying here is, in Georgia, a high school senior reads an article stating that only 49% have a driver's license. So that's the status quo. I'm saying that my percentage is 49. That's my status quo. But if you keep reading, she says she claims that the percentage is less. And so I'm going to start writing what that looks like. So this is my claim, and I'm going to say it's my proportion here is less than 49%. And that's how we're going to start setting these things up. Now, there's so much more involved here, and I'm going to start telling you how it works. But right now, we're starting with the null and alternative, the status quo, and the claim. Alternative. Okay? Is this somewhat making a little bit of sense right now? Right? We're making a statement, and then we're changing. We're saying, nah, I think that's going to be different. Good? On the homework, this is question number 1 on homework. On the homework, they will not just leave it there. They're going to ask for tail tests. And this is very simple once I show it to you. I'm going to scroll down 2 pages. I think it's 2, maybe 3 pages. See you later. Thank you. So right here, see how it says left tail test? What tail is on that side, or what side is that tail on? That's on the left side, isn't it? What about this tail right here? On the right. What about this one? How many tails does it have? And those are the 3 options that we have, okay? So it's either going to be left tail, right tail, or 2 tail. Less than, greater than, or not equal to, okay? So I'm going to use that a lot going forward. Right here. See how it says less? So then I would be then on the left side. Exactly right. If someone said, hey, draw a picture of what that bell curve would look like, it looks kind of like this. This is what I'm thinking it's going to be. Somewhere here on the less than side. That's my claim. Now, we haven't been able to test any of this yet. We're just setting it up. And I'm going to set this thing up about like 20 million times for the last few sections here. You help me a little bit with this next one. I know y'all can help me because this is easy stuff, really. So the next one, it says, recent studies suggested 75% of people take medication, blah, blah, blah. What would I be putting here for the status quo? 100% true. There it is. We're starting with the fact we got 75%. Keep reading. It says the doctor would like to know if the percentage is higher. So then what would I then be putting down here? Perfect. I always put a little thing here that says claim. I don't always write status quo because I kind of already know that one. But I'm going to write claim at the bottom often because it's going to be useful when I start talking about the decisions we make. On the homework, they're going to say, hey, what kind of tail test is this? And this is greater, so it's on the right side. You got it. And if somebody asks, hey, what does a picture of that look like? It would look like something like this on the right side. Cool? This is what your homework looks like. It literally is multiple choice. You click, 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 and there you go. So pretty straightforward. Help me out again. Civil engineers interested in building plans. It is known. See the status quo here? It is known that the average is 670. So the average, we have to use a mu. But that's whatever. What would I be continuing with here? What's the rest of this up here? What's my status quo? Say it. Equals 670. Very good. Very good. After studying further, a civil engineer he claims that the average is different. So what then would I use? What symbol would I say for different? Not equal. Very good. Not equal to. And again, that's the claim that he's making. He's saying this is different. Okay, so if we had less than, it's a left side. If we had right, it would be the greater than. But I have not equal to. What kind of tail test can you think it is? There's only 3 options. Two-tail test. Yep, a two-tail test. And again, if somebody's asking, what does that look like? It's a little bit on this side, a little bit on this side. Now, all of this pictures, all of the two tails, all of this stuff, that's all in StatCrunch. But it's not in the section even. I never touched StatCrunch for this whole section. But when we get there, we're going to do StatCrunch, and you're done. So very quick and easy once we start getting to the math side of things. Are y'all cool with this so far? Pretty straightforward. Okay. Now, this one right here, let me tell you, this is a big discussion right here. I don't really like getting into it as much because on the homework, they just do like 2 questions about it, multiple choice, and you walk away. So I really don't want to go too deep. But I do want to say that this right here, this table is pretty important, and that this is not very important, okay? I talked with one of the other professors, and she says it's very important to talk about it. I don't know, but let's do a court system. Let's do a scenario. It says we have the truth and we have a decision, and they're saying do not reject and reject, true, false, and all that kind of stuff. Okay, I'm gonna make something up on my own, if you don't mind for a second here. Let's do a murder trial. You want to do a murder trial with me? Okay, let's do a murder trial. Okay, so let's do the truth. That the murder is a true thing. So basically, the murder, he was the murderer, and all that kind of stuff. So they caught the murderer, basically caught. The murderer. Versus the other way is they caught an innocent, right? They caught an innocent, someone who was not actually the murderer. Innocent. Okay. But then we have to make a decision about these people. And so it says like either we accept the original, that he's a murderer. So basically we're going to say, do the gavel, guilty is what we say, right? Guilty. Versus we reject that he was the murderer. We say he's not guilty. These are the 2 options, right? So we have somebody on trial. We caught the murderer, and we say he's guilty. We caught the murderer. We say he's guilty. Wouldn't that be a correct decision? Right? What if we only caught an innocent and we said he was not guilty? Wasn't that also going to be a correct decision here? Right? But now, what happens if something goes wrong? Right? The trial system, something is just not supposed to happen. And here we go. What if, I say guilty. What if we had someone that we say, "No, you're guilty," yet he was innocent? That's not good, is it? This is called a type 2 error. And that's that little right here. That's that type 2 error thing, okay? What if you actually caught the murderer? You have him in trial in the court, and you say not guilty. That's not a good thing either, is it? That's called a type 1 error, okay? And that's this guy right here. You see how that's an error, right? So I guess my other teacher really likes this one. She says, which is more serious? I'm going to go ahead and ask you guys. What would be more serious? Being an innocent going to jail forever? Or having a murderer still run around the streets? Which is more serious? 6-7, right? No, I'm sorry. But like it's a tough call is really what it is, right? It's a tough call. So I don't really know if I could say one's more serious or not, but I could say that they're both not good. All right, so what would it look like then for parachutes? What would it look like then for buying a house? What does it look like if I make a mistake in some of these situations, okay? So I don't want to go too far on this. I just want to show you some basic stuff here. So let's say that we have the parachute failure rate is 0.01%. And then over here, it's going to be higher than 0.01%. Okay, so those are the 2 options for the parachutes. And then here, whenever I say do not reject, what does that feel like in real English? Give me like a better one word phrase. So do not reject. If you're not rejected, you're actually going to say no, the opposite. What? Say it. Accept. Accept, right? That's and this is one of those things where you're getting a Chad version here, right? Do not reject. The opposite of that was be accept, right? And then, of course, it says when it says reject, you just reject. Okay, so here's the thing. If the parachute failure rate is really low and you accept the parachutes, then all is good. If the failure rate is really high and you reject them, that's really good. That's fine. You move on to get a different parachute, right? But what if you accept the parachutes even when they have a higher failure rate? What happens? Say it. You're saying, yeah, parachutes are great, bro. And then they start failing in the sky. People die. People die, right? That's not good. Here's another one. What if the failure rate's really low, but you say, no, I don't think your parachutes are that great. What happens here? You just lose money, yeah. So you see how here, like which one's more serious? That's kind of what she was wanting to talk about. And I think that's an okay discussion. I just don't know about the murder case thing. One more. We're almost there. It says the average price was $240,000. And so I'm going to say that the average is at $240,000. And then they're saying it's lower. So I'm going to say it's lower than the $24,000. Okay. Cool. So again, I'm going to use the word accept and reject. We're buying a house now, guys. We're buying a house. So I buy a house, and the average is 240, and I buy it for 240. That was great. See you later. The average for the house was less than that. Oh, I think we're selling it. I'm not buying it. We're selling it. It's less than that, and so I say, no, I'm not going to do that thing. So that would be a correct. Okay, but what happens if I accept that the mean was this much, but really it's lower? Yeah, overpaid. Versus here, if I reject that house, even though it was a good price, bad deal. I like that. Or maybe like move on to the next one, Exactly. So which one's more serious here, right? Maybe you lost money, but there you overpaid. Again, it's just a discussion topic. You can see how this kind of works though, right? There you got a one type and a second type, yes? Okay, cool. I'm going to move on. But y'all kind of just, it's more like a discussion. Good? Good? Okay, cool. Moving on. Well, like the whole workbook? Yeah. Okay, real quick, right here, this guy right here, that's homework number 7. They're going to ask about it, and they're going to say alpha is, not if, is for the type 1 error. They're going to say, hey, which one is for type 1 error? And you're going to say alpha. Okay, so that's what you're going to use there. See you later. See you later. Okay, I'm almost done. I think I might be done already, but let's see you later. There's the tail test. Okay, and then we move on to this thing. Can I just do these last two? And they're so super fast. They're on the homework. And this culminates what all we've been doing. They give you this. And they're saying, which one is it? From this right here, is it left tail, right tail, two tail? That is a right tail test. One way for me to remember is which way is it pointing? Exactly. See how that's a quick, easy go-to. So it's a right tail test. What's being tested? See this P right here? P stands for what out of these three? Proportion. Yep, proportion. Yep. And that was the entire problem. That's literally question 4 on your homework or whatever it is. I got one last one and then we're done, okay? I swear, we're almost done. And thank you guys for hanging out with me, okay? This guy right here. There it is. Left tail test. Again, if somebody asks, what does that picture look like? It's going to look like this. Exactly right. Left tail test, and that right there is a standard deviation. Perfect. I get you. So the rest here is more about decisions and other things, and I think they're really great, but it's a good starting point when we come back later. Good? Any questions? Thank you, guys. Thanks for hanging out. Y'all have a great day, guys.